Here, today we will discuss about the polarization due to reflection and refraction, partial reflection and reflection. What we have seen practically, Brewster, one scientist is there, they have experimentally shown that when a light rays fall upon a transparent medium, which partially reflect the lights, partially reflect and partially refract. So what they have seen, at different incident angle, when light falls upon the transparent medium, at particular angle of incidence, they have seen the reflected angle, reflected rays or reflected wave is completely plane polarized, while refracted rays are not completely, they are partially polarized, but reflected rays are plane polarized. So Brewster has made some laws. See here, polarization by reflection. Brewster law. When light incident an angle, particular angle on boundary between two transparent medium. I have taken the transparent medium. The refractive index of first medium I have taken mu1. Refractive index of second medium I have taken mu2. Incident wave I have taken unpolarized. Here I have shown the unpolarized. This dot will show the direction of electric vector perpendicular to plane of paper, and this arrow show the direction of electric vector perpendicular to the direction of ray, but lie on the paper, plane of the paper. When this ray falls upon a transparent medium, mu1 is refractive index of first medium, mu2 is refractive index of second medium. So what we have seen, this unpolarized ray, when this falls upon this transparent medium, they are partially reflected. This is the reflected and this is refracted. So they have seen that this reflected rays are plane polarized, and electric vector, plane polarized electric vector is perpendicular to plane of paper. ये भी देखा हमने कि जो इलेक्ट्रिक वेक्टर है वो क्या है, उसका डायरेक्शन इनसाइड प्लेन ऑफ पेपर नहीं है बल्कि परपेंडिकुलर टू प्लेन ऑफ पेपर है डायरेक्शन. And this refracted ray, this is partially polarized. So see here, this dotted dot that will show the direction of electric vector perpendicular to plane of paper, and this arrow will show the direction of electric field in the plane of paper. De Brewster experimentally discovered for a particular incident angle, the reflected wave is completely polarized with its electric field perpendicular to plane of paper, while the refracted wave is partially polarized. Remember one thing, for particular incident angle, only for a single particular incident angle, the reflected rays is completely plane polarized and direction of electric field vector is perpendicular to plane of paper. See here, one thing they have seen, the angle between, at that particular angle that I have here taken IP, that angle is known as Brewster angle or polarizing angle. So at polarizing angle, what we have seen, the angle between reflected ray, this is reflected ray, this is refracted ray, the angle between reflected ray and reflected ray is 90 degree, or you can say the reflected rays and refracted rays both are perpendicular to each other. एक स्पेशल वहां पर हमें ये भी मिला कि at polarizing angle or Brewster angle, what we have seen, the partial reflected and partially refracted ray, both are perpendicular to each other. So see here, if IP is angle, this is the angle of incidence. We know angle of reflection is equal to angle of incidence. That's why this angle is also IP. I have given the name A, B, suppose C. This I have given D. This separating surface is MN. So see here, this I have also taken PQ. So angle ABP, angle of incidence is equal to angle PB, angle PBC is equal to IP. See here, PB is normal to the MN surface. That's why angle CBN, this angle, if you will see this angle, so this angle is, this is IP, total is 90, so this angle is 90 minus IP. So see here, PB perpendicular to the surface MN implies angle CBN is equal to 90 minus IP. Similar way, see here, angle QBD, see here in the figure, this is refracting angle, this I have supposed R. What angle DBN? This total is 90 from here to here because QB is perpendicular to MN. So this angle is 90 minus R. So see here, from here to here, this angle is angle DBN. Angle DBN is equal to 90 minus R. I have told at the polarizing angle, the reflected, partially reflected and partially refracted, both are perpendicular to each other. That is angle CBD. This angle CBD, total angle is 90. So CBD is sum of this CBN plus NBD. Angle CBN plus angle NBD is equal to 90. CBN is, I have here finded 90 minus IP plus 90 minus R is equal to 90. So this 90 cancel, 90 minus IP is equal to R. One thing I have finded, 90 minus IP is equal to R. So see here, what we know by Snell's law, when a light rays is refracted by Snell's law or laws of refraction. So by laws of refraction we know sin I upon sin R is equal to refractive index of second medium with respect to first medium, that is mu2 upon mu1. So here I have got it, R is equal to 90 minus IP. R is equal to 90 minus IP. So put here I is equal to IP, incident angle. R is equal to 90 minus IP, mu2 upon mu1, or sin IP, sin 90 minus theta, cos IP is equal to mu2 upon mu1, or tan IP is equal to mu2 upon mu1, or IP is equal to, Brewster angle is equal to tan inverse mu2 upon mu1, mean refractive index of second medium with respect to first medium. इसी को हम क्या कहते हैं बेटा, this is called Brewster law. What is Brewster law? Brewster law को हम कैसे explain करेंगे? When a light is partially reflected and refracted from a transparent medium at a particular angle of incidence the partially reflected rays is completely polarized, that angle is known as Brewster angle, and tangent of Brewster angle is equal to refractive index of second transparent medium to first transparent medium. So this is called Brewster law. See here, actually the same thing also happening when there is a scattering process takes place. There is also polarization by scattering. Same thing is there when light waves fall upon dust particle or air molecules. Scattering is taking place. If they are falling at different angle, there also partial reflection and partial refraction takes place. When the same thing is there, when angle of polarization is equal to what happen, tan inverse refractive index of molecule with respect to surrounding medium. The same thing is happening. The reflected rays are completely plane polarized, while refracted rays are partially polarized. The same thing are happening when light waves falls upon dust particle and air molecules. When scattering takes place, the different angles scattering we have seen. So there are also sometimes when angle of incidence becomes polarizing angle, or you can say when partially reflected and partially refracted are at right angles, that time their partially reflected rays is completely polarized, plane polarized, while the refracted rays are partially polarized.